In the second part of Lesson 1, we're going to discuss relational database design. We'll begin by introducing you to the concept of a flat file database, which is the type of database that many people start with. However, the real power of Access is in using relational databases, and we'll show you exactly what we mean by that. The example that I'll be using as we work through all the lessons in the Access Basics is a library database. And eventually we're going to have a functional library database that will keep track of patrons and the books in the library, and then also be able to do some historical tracking of when the books were checked out and when they were returned. But however, we're going to start with a flat file database, and the flat file database appears to be functional, but it really will not do all the things I just described. With flat file databases, we typically cram as many fields as we can into a table tracking what we think needs to be tracked. So in this example, I have a table called book checkouts. You see the fields. In this particular table, I have an ID field, which is the primary key. I have the date that the book was checked out. I have the title of the book. I have the subject of the book, the cost of the book, and then of course I need to know who has the book. So I have a field for the first name, the last name, and I need to be able to contact them. So I have the address, their city, their state, and of course their all-important phone number. Now, with the flat file database, let me explain how this works. Let's assume that I want to go ahead and check out a book. So I'm going to close the table, and I've created a form to check books out. So I'm going to go ahead and enter a new record here. And so the checkout date, and I'll just use the date that I'm recording this video, which is the 21st of November. The book title, let's go ahead and put in War and Peace. The subject in this case, we'll just call this fiction. And let's say that the cost of the book is $15.95 in case the individual does not bring it back. All right, the person that's checking this book out is John Smith. And he's at 123 Main Street. And we'll put him in Boise, Idaho. And we'll put in his phone number. All right, that's superb. So we'll go ahead and enter this record. And now we're ready to enter another record. And John Smith just brought another book to us that he wants to check out. So once again, I'll go to today's date. The book title, he's interested in cats. So cats make great pets. The subject is pets. This is a $4.95 book. And again, we have John Smith, 123 Main Street. Are you getting the idea here that if he had 10 books here, this would be really, really annoying? That's the problem with a flat file database. In fact, let me go ahead and close the form here. And now let me show you the table. This is the table that form was based on. So I want you to notice in this case that we have an awful lot of repetition. So while this flat file database may be functional, it really is not very efficient. Notice that each time Felicia Andrews has checked a book out, I have to type in all of her complete information. Same thing for John Smith. And can you imagine how frustrating this would be for individuals that checked out 10 or 15 books at a time? Well, the solution is going to be working with a relational database, and I'll explain that now. As we've just seen, one of the major disadvantages of a flat file database is the fact that you're repeating the same information over and over and over again. For instance, when we were checking out a book, we had to enter the information for the book as well as the information for the patron who checked the book out. And so if that patron had 10 or 15 books, I would have to enter that information 10 or 15 times. Now imagine what would happen after years and years of using that database. That same patron's information might be in there 1,000 times if they were a heavy user of the library. The solution is to break that information up into different tables. And so here you see an example of a much better structured database for our library. Instead of just having one table tracking patrons and books and checkout information, we've separated this into 3 different tables. In the patrons table, I have the basic information about the patron, and I only have to enter that one time when the patron enters the library for the first time to get a library card. I don't have to enter that information again and again each time they check out a card. The same thing for books. When a book comes in, I enter it into the books table. Now notice that both the patrons and the books have a primary key, which is card number for patrons and book ID for books. That is the unique identifying value for each separate patron and each separate book. So every patron has a different library card number. Now to make this magic happen, I have a third table which we call checkout history. And in the checkout history, instead of having the book title, the author, the subject, and the cost, I just only have to put in the book ID. That then links to the books table. So when I type in book number 202, it links to book number 202, and I can then make a report or a query that's based on both tables that would give me the information such as the title and the author of that book. The same thing is true for the patrons. When somebody comes in and checks out a book, I only have to put in their card number. And when I put in their card number, then I have the ability to link and see who that information is. Now, I also, in this table, can check historical data. I have the date that the book was checked out, the date that it was due, and the date that it came in. And of course, I also have a condition field. And so by having this table, I can go in and see how many times a specific book was checked out over the last year, or how many times John Smith checked a book out over the last year or 2 years. Now, to give you an example of how this works, I'm going to open up a different form for checkouts, and I'll start with a new record here. So I have a new checkout ID, and so I have the date for today, and I'm going to put in the book ID, and I'm just going to put in book ID number 7. And as soon as I type number 7, notice that it fills in the information. That's because this form has information from both tables. So the same is true for card number. I'll put in card number 5, and now I have the information all filled in. Now the table is only storing the book ID and the card number, and so it's going to take a lot less space in the file. We'll learn how to do this through database relationships, but at this point, when you're working with designing a database, you want to be able to think, how can I track this information without having to repeat again and again the same information? So like I said, in this case, we have a patrons table and a books table, and then our checkout history allows us to link them together. And notice that this checkout history would actually become the table that has the most records as I begin to use this again and again and again, but the data that it's storing is very minimal, just numbers as opposed to lots of data. So that gives us a start on how to work with relational databases. We'll build through this example as we continue with the lessons in this book. And just a quick reminder that these lessons are all part of the Microsoft Access Basic books that you can purchase on Amazon, and you can get additional resources on my website, luthermaddy.com.